Hello guys, welcome to Stratford Tutorials. In this session we will be discussing about the time history analysis of a structure. So let us begin the session. Initially we will start StratPro and select space frame. Then you will go to Geometry Run Structural Wizard. Select frame model, select Bay frame. Select structure, create a structure. Then transfer the structure to main StratPro screen. Now you can switch off the grid. Here you can see there is our structure. We'll be carrying out the time history analysis for this structure. So let us begin. First we will go to general. We'll define a property to the members. Let it be rectangle 0.4 by 0.3. Assign it to the entire whole structure. Then going to supports, create a pinned support. Now the basic information we required for time history analysis is that time history analysis is nothing but analysis of a structure over increment of time as a function of acceleration or maybe force or maybe moment or displacement. It is just the analysis of time versus acceleration, या time versus force, या time versus moment, या time versus displacement. Or else it is simply the response of structure evaluated as a function of time, in simple words. So in order to begin time history analysis, we have two steps. First is defining the time history analysis definition, then assigning it to the building. Second step will be. So first we will go to select loads and definitions, select definitions, give double click and select time history definition, select add. A dialog box opens. First let it be the type 1. Type 1 is nothing but it will be starting first one, and loading type let it be acceleration. You can also keep force and moment. And coming to function options, if you have time and acceleration you can provide, or you can save it from an external file. This external file should be saved in the same directory where this start file is stored. So as of me, the time start profile is stored in this folder, and also the external file, you can see it consists of data for time and the acceleration. It is also stored in the same folder. It is eqdata.txt. We will just note it down here, eqdata.txt. Now you select this save button. Now select add. Then go to define param. Time step is, in simple words, it is the time increment used for analysis, and arrival time is the time at which the assignment of load begins. It can be even positive, negative or 0, and it begins at time 0 by start default. So we'll give time step as 0.02, which will be increments of, there will be time history analysis in increments of 0.02 seconds, and arrival time for 0, 1, 2 and 3 seconds is given at where the load assignment begins. select add. Now close it. So we have done with the first step of defining the time history definition. Next, going to load case details. First, select dead load. Select self weight. Loading type will be dead. Second one will be dead load, floor load or slab load. Loading type will be dead. Third one will be dynamic load, and loading type will be seismic. Select add. Now going to dead load self weight, select add, give self weight in y direction. Select self weight, assign it to the view. It means the whole structure. Next, going to dead load floor weight. Select add, give floor load, which will be minus 12 kN per meter square in the range of 0 to 12 meters in y direction. Select add, plus you can see it. Then going to dynamic load, you can, just to avoid confuse, you can note it down. Now select dynamic load, select add. First we will be giving self weight in all the three directions, and it should be +1. Factor should be +1, and the load should be same in all the three directions. We have also provided floor load 12 kN per meter square in the range of 0 to 12 meters in all the three directions, in global X direction, in global Y direction, and in global Z direction. Now assign the self weight to the view or the building. Now you can see the load being assigned. So now select dynamic, select add, go to time history load, select ground motion. You will select arrival time as 2 seconds. Defined type will be acceleration, and direction is given x. Amplitude factor, you can keep it as 1.2 or 1.5, or else you can give 2. Select add, close. Now you have done with the second step of defining the time history to the building, assigning time history loads to the building. Now you go to analysis and print, select mode shapes or no print. Select. The one thing you need to do before all this is you need to provide mode shapes by going to commands miscellaneous, cut off mode shape, keeping to default 6, but we like have 25 or 30 mode shapes. Select OK. Now we can go to analysis, select mode shapes, select add. Now going to post print, you will define command analysis and results. That would be sufficient. You can even add mode shapes. Now analyze the structure. So you can see I have done a simple mistake. Actually need to take care of all those here. In I given Yeah, this was open, so just close it. Now run the analysis. Let us see if it can. .txt. Well, everything is fine. Then where is the mistake occurring? Okay, so this might not be the. Actually, this should be it. Let us open that file and see what does it contain. Actually, it is another file. So we'll copy this file and we'll go to the files where the StarterPro files are locked or present. We'll paste it here. Now run the analysis and see does it run or not. Yes, it runs. Actually, the file was in that folder but not in this, in the th folder. So you need to take care of that to avoid miscalculations, errors. Now go to output file. Well, you can go to results directly. You see eigen solution for 25, 30, whatever taken is provided, and the next is for extra 6 members. Well, you can see the mode shapes are also provided. Coming to participation factors, easily 90% is achieved in the first few mode shapes. You can see modal damping used in analysis is 0.05. Well, coming to here, time step used in history analysis is, as we took, 0.02 seconds, and the number of modes considered is 30. We took it. Time duration was 34.16 seconds, and number of time steps were 1708. So you can see maximum base shear in x direction, y direction and z direction occurs at time provided. Well, in this way we observe the results. Now going to post processing. Okay, you do one thing, create few combinations. that would suffice. Select add. Now analyze the structure once again. As you have observed the output file, however, we will go to post processing directly now. In post processing, we'll consider the three combinations: removing the nodes, loads. Only three combinations selected will be considered. Select OK. Now going to dynamics, you can see the modes and the different mode shapes occurring for different types of modes. Their particular details are given here. Then going to time acceleration tab, it asks you to create a node group. Select yes and select the node group as roof. We will be considering roof nodes. Select OK. Now select the nodes. Select the roof nodes carefully. Or else you can select front view and select the roof nodes easily. Then going to other view, so all the nodes are selected. Now select associate. Okay, now you have selected. Now close it. Well, now select the particular node. You can select even other nodes and it gets created. So as you can see, the node, this is the node 56 and the graph is shown for acceleration versus time. You can see this here, node for node 64, for node 63, for node 25. Now going to time displacement, you can select the node and observe the time displacements. Well, you select on the deflections. Well, you cannot view since the scale would be very small, so you just go to results, select scale, and decrease the scale. Select the structure, go to scales, decrease scale, select apply. Okay, well, Here it is little difficult, however for that particular node you selected, you can see the deflection different times, and for different load combinations too. For different modes also, as you can see here the deflection occurring. Let us see by going to results, selecting scale, decreasing it if anything happens. So you can see for mode 26, however the deflection can be observed in that way. So in this way the time history analysis is carried out for a structure, and this would be the end of the session. For more videos, subscribe to this channel. Thank you. However, just a second, hang on. Okay, you see this node. Okay, you see this node, and here it is displayed in feet, 41.1 feet. So if you go to time acceleration, just a second, go to time displacement, select for roof, an average of 40.4 of all those nodes is given. The displacement is 40.4 in feet. So if we want to see the displacement, you select the deflection tab and go to results, select scale, decrease the displacement. If it is in feet per meter, decrease it to such a level to so much small, and select apply. If it is in meter, 0.7, 0.07 would be sufficient. Okay, now you can, using this button, you can see the deflection occurring at different times. And also for different modes. So in this way time history analysis is carried out. Thank you. This is the end of the session. Subscribe to this channel for more videos.